This is Greg Troutline with Maritime Reporter TV, and we're here today with Siemens Energy's Ed Schwartz to discuss electrification in the maritime sector. So, Ed, to start us off, can you start from the 50,000-foot level from your point of view? I know this industry is very broad and deep in terms of vessel size, trading pattern and type, but on your cut line on LinkedIn, it says electrify everything. And I guess the question is, where specifically are we as an industry in the adoption of electric solutions on board commercial vessels?
So if we look at the maritime industry, obviously a lot of different types of vessels, different segments that they operate in. The profile is very vast. In fact, there's probably more similarities out with the marine industry has in different segments outside than they do with sometimes their own fellow sailors as these vessels get very, very specific. But having said that, I don't think that there's a segment type that hasn't discussed electrification or hasn't seen some benefit to it. And when I say electrification, I'm also talking about like hybridization. So not just all full electric, all battery operation. In some cases, that's available today. There are vessels that are operating all electric, realizing the benefits of it. But even in these hard profiles of large ocean-going vessels, we're seeing more adaptation of PTI PTOs, adding energy storage to container ships. So some of these vessels that we thought would be further off from electrification are looking at it now. And then you have a lot of vessels that have been electrified for a long time on the oil and gas industry using diesel electric systems that are now looking at the benefits of hybridization. So I've been in the propulsion business for a while. I would say I felt like a lot of my career I was advocating for technology into the space, but I would say with electrification, I feel like we're being pulled into the space from many different vessel segments. So I stand by electrify everything. Maybe not electrify everything today, but I think eventually that's the direction the industry is going.
So everybody likes a good case study. How specifically company XYZ has been able to adopt this new technology, navigating the hurdles and hopefully prospering along the way. A landmark case, which actually, when it was put to my attention, that Ampere is now 10 years old. That actually made me feel very old because at the same point, it felt like it was yesterday. So, can you discuss Ampere specifically, remind our viewers, and also Siemens Energy's role in that project?
Absolutely, thank you. Yeah, Ampere is a great example of what's possible, and it's funny how quickly time goes by when you look at these anniversary dates. So yeah, so 10 years ago, which means the process was started actually prior to that. By the time you constructed the vessel, did all the design work, so it was probably even 15 years or more a while ago that people were looking at this technology and utilizing it. So the Ampere is a ferry that operates in Norway. What I like as a reference, and I think it's kind of a universal reference to many segments, especially the ferry segment, is it shows the evolution of the technology. So at the time, the vessel was constructed to be a hybrid vessel to operate in a hybrid mode, sometime under zero emission using the batteries, and then sometimes under diesel generators. And the infrastructure wasn't in place at the time for charging. So they built a vessel, they built a hybrid vessel. It performed very well, but the intention was always to increase the zero emission of the vessel by adding the shore charging, by reducing the generator usage on board, and that's what they've been able to do over time. So now a vessel that started out replacing a route that was done by a diesel mechanical boat was started as a hybrid boat doing partial emissions cut to now being fully electric and zero emission, and shows like I said, the evolution of the utilization of technology, which I think is important to this segment. I think in the maritime industry and most engineers, it's a problem to solve. So we say, okay, emissions is a problem to solve. We jump quickly to the zero emission solution, which is the end of the goal of the calculation, but it's not always possible with regard to the technology, in regard to the infrastructure, with regard to the budgets of the owner. So what we like to look at as Ampere is a customer that seems very, very happy.
As Ampere was indeed a landmark case, and you already mentioned Siemens, you've been closely tied to the project, as I assume that you would be through the various ups and the various downs. I guess from where you sit today, what are the key takeaways in terms of vessel performance and emissions? In short, what's the good news emanating from this project?
So the good news is it's funny. There's a few different areas when we talk to owners, and I talk to vessel owners, and one of the questions I find most difficult to ask, because I'm sometimes afraid of the response, is, would you do this all over again if you could rewind back the clock, 5 years, after you're sitting on the boat, you're commissioning it with the owner, and you say, okay, would you have taken this journey again? Um, Surprisingly, every single one of them has said to me, yes, they would. They would do it again. They may do some different things. So then that's what we concentrate. So then I say, okay, well, what would you do differently, in order to get to this place, maybe a little less scarred up, and a little bit less seasick from the process, is kind of where we then look at. So it's encouraging that the majority of owners, or all the owners I've spoke to, said that yes, they would build a hybrid boat again. They advocate for it, which tells me that yes, it's worth the squeeze is worth the juice is worth the squeeze, as they say. Where there's areas for improvement, I think it's the learning curve process. It's the owner's learning curve. It's certainly within Siemens Energy and integrator role. It's our learning curve. It's the shipyard's learning curve. And what we're seeing now is we're out of that first adopter infancy stage. I mean, I think I saw released this year was the 1,000th vessel with hybrid batteries included is in operation. So after you get out past 1,000 vessels, I think as an industry, you can say is like, yeah, we're kind of getting certainly not serial production levels, but the knowledge is getting there. The lessons are being learned. The initial design efforts are being lowered a little bit. I think that's always been painful for owners. Is you're on a journey to build a boat, but then you spend a lot of time and a lot of resources doing a lot of initial designs to see what's feasible. A lot of feasibility studies, a lot of trade-off studies come into effect early in the project that kind of prevents you from starting construction, and eats up a lot of your budget. But we're seeing those things coming down as we're able to kind of move with more off-the-shelf designs. There's more integration that's understood within the systems. So I think that was part of the painful part that's being improved. But in general, I haven't come across an owner yet that said they wouldn't have done it, and also has in mind becoming a advocate for the technology too. It seems like everyone who's done this and adopted it, and as we know, sometimes bad news travels faster than good news, but it's been mostly good news. So I'm very, very happy about that.
As I believe that you'll agree, every engineering project, particularly a pioneering one, comes with challenges. In fact, as I said, I've been doing this 30 plus years. The absolute best interviews that I've ever had have always been with engineers. And usually the best information always comes with the caveat, you can't print that. But can you get a little more specific, I guess, as you
Sure.
can?
Oh, absolutely.
What have been some of the specific challenges? And we don't even really have to limit it to Ampere, because I know your experience goes far beyond that. But just in general, what are some of
Correct.
the challenges? And the people watching this are vessel owners that hopefully are thinking of making this switch. What are the challenges, and how have some of those challenges been overcome?
That's great. Yes. So I see we have basically three major challenges when we look at hybrid projects. One is probably the most important, is budget. So as you said, it's fun doing the engineering. It's fun thinking about the engineering, but ultimately these are commercial projects. Even if it's a public entity, it's still a commercial project. And the most heartbreaking of projects are well-intentioned owners, really trying to build the best boat, doing the most they can with the resources and assets they have, spending a lot of time engineering a project, and then the project exceeds their budget and doesn't get greenlit. And this is for everyone involved. I think this is probably the most frustrating, because we all do this for the end result. It's not a theoretical exercise of designing vessels. Everybody involved in the process wants to see a vessel hit the water, and be a great asset for what could be the next generation with a lot of these vessels. So really what we need to do is design to budget. and to, instead of saying what's the best vessel that could be built with the technology today, is really what's the best vessel that could be built with the technology today within your budget. I think that's, if I was to go back again and put myself in that time machine I talked about earlier, what I would be doing differently 5 years ago would be introducing budget conversations much earlier. That is probably the number one thing I see within how do we get more adoption of hybrid systems of electric propulsion within the industry. It's as an industry, between the integrators like Siemens Energy, between the naval architects, we need to figure out how to be able to implement the technology in more cost-effective ways, is really the problem. So that's the number one challenge. The number two challenge is really kind of, if we're going to look towards the electrification shore side, in order to charge the vessels, if we're talking about ferry electrification in particular, that introduces a lot of complexity. And sometimes the infrastructure and the utility power isn't there, or it could be too expensive when it comes to peak demand charging and these types of things. So that's kind of a limiting factor that we still need as an industry to kind of figure out. Vessels, I think if we were to kind of rewind 50 years ago, if you were designing a vessel, the most independent autonomous vessel you could build would be, the best design. If you could make your own water on board, you had your own sewer streaming, your own electrical plant, your own, like as independent as you could be of the shore, would be the best vessel you could design. And now we're looking at, in order to integrate this hybridization, it's the opposite. We need to figure out how do we couple vessels with the utility? How do we couple vessels with the infrastructure shore side? It's the trade-off that comes with this technology, but it's new to the industry, and we haven't been looking at that in the past. Most operators are not aware of the utility power and how far away a high voltage transformer is from their operation, and how costly it is when it's not close by. But again, it's designing again to that budget of where you are today. If you're going to build this asset that's going to last 40, 50 years, sometimes in most cases it does in Jones Act vessels, how do you design the best vessel for the technology today? And then later, as things develop and the utility gets spread, then we can see more adaptation of utilizing the shore side, but not to allow the shore side to kind of crush the projects because it's not available today is the other challenge. And then the third challenge, which I see is getting much better, has been the approval process of new technology. So obviously, especially in the United States, a lot of these vessels that we're talking about are not classed vessels. So they're kind of just to the flag state or to the U.S. Coast Guard approval. And a lot of the CFRs have not been fully defined around this technology. But what's been great is MSC and the U.S. Coast Guard has been very, very helpful in making sure that these projects go forward and making sure that we can marry both the new technology and the emissions savings and safety at the same time, and not compromise on passenger safety. So it's taken this ability for exemptions and approvals. It takes sometimes a little bit longer. There's a little bit more risk involved to the project because you start a project and technically you don't know what the finish line looks like with what's going to be accepted. But now we're starting to see that kind of narrow. Again, when we get these references, when there's hundreds of electric propulsion vessels in the United States, you're starting to see the rules kind of getting written with all the previous acceptances. So I think that one will probably be the hurdle that was maybe 1 or 2 in the years past is now shifting to 3 and will eventually slough off, and we can concentrate solely on budgets and shore power.
All this stuff comes with a learning curve. It all comes with a learning curve. And I assume, I think you referenced 1,000 vessels today now with battery energy storage on board. That learning curve will pick up as the technology evolves. But I guess for those watching, for those who are even considering taking this electrification journey, what's the best first step?
That's good. So, what I would advise everyone is to, as anyone who's a graduate of King's Point it's to kind of find the pony, as we used to say, is find the previous exams from that professor to figure out what's going to be on the next test. And it's the community. The one thing that's, or maybe not unique, I've only spent my entire career in the maritime industry. I don't know too many other ones, but one thing I love about the maritime industry, it's a very collaborative industry. So there's so many, now that we have so many, kind of pioneers out there, these companies like the Ampere, or the vessel like the Ampere, there's a lot of experience to be shared. So my first conversation would be, get on board a vessel, talk to an owner who's done the journey. That's going to be, the least amount of BS, the straightest shooter you're going to find, the most comprehensive information. And the beauty is, it used to be, again, if we were talking 5 years ago, 8 years ago, you'd have to hop on a plane and fly to Norway and spend a couple of weeks, which I would advise to anyone who had that opportunity to do it. But if you don't need to go any longer to Europe to get on board these vessels. These vessels are operating in North America, in the United States, and they are usually in a public service and available to you. So I highly encourage people to, visit a vessel, talk to that owner. These owners love talking about their journeys. That's the best first step. And then after that is, okay, then start to map your path, to figure out. The other big conversation around this is the grant funding. If you're a public agency and you're going to apply for grant funding, to set that budget. Because again, we talk about the budget. Well, usually you're doing your investigation, you're trying to figure out what kind of vessel you need, even before you've defined your budget. So then the next part of that process is really trying to figure out what's going to be your avenue for capital to build the vessel, and that'll dictate a lot of your design. Again, not to fall in love with a design from day one, but rather kind of take in as much information as you can, and then figure out your budget, and then start working with companies like we would love to work with anyone at Siemens Energy to kind of educate people. That's where we kind of see our goal, and our job is really kind of more of a helping hand in education in this process. We spend probably equal amount of time and capacity developing solutions as we do executing solutions. So a significant amount of our capacity and time in engineering is helping owners and figuring out what that solution looks like, because it's not like I'm sometimes glad and sometimes disappointed that we don't have just a catalog to offer everybody and just say, hey, just turn to page 52 and item 34, and that's exactly what you're looking for. It's never that. It's more, okay, you want a vessel that's a certain size to go a certain distance at a certain speed. Okay, now we can start getting out our abacus and start trying to do some calculations. So that's more than figuring out those partners that can help to kind of define the system that you're looking for and what is possible with the technology today. And then one thing I would caution anyone who's starting this journey is to just be careful of and I feel like a lot of people are suffering from it, this kind of like hybridization malaise, where you can attend 1,000 conferences and hear a million people like me pontificating online and these types of things, and it just gets overwhelming, and there's just so much, and a lot of platitudes and things. So it's hard to take action when, now that there's probably been 5 years, 6 years of everybody kind of promoting solutions in this space. It's kind of hard to sift through it all.
Can you discuss in general? I mean,
Yeah,
when you're
sure.
talking about a hybrid vessel versus a traditionally powered vessel, what kind of premium are you talking about?
Correct.
And how do you make that case for the investment is X, the result is Y?
That's a great question, and it is varied. So you could be looking at a 5% increase to a construction cost of a vessel or less. If you're talking about an ocean-going vessel and you're adding a PTI system, which is relatively inexpensive to the cost of the vessel, but will generate, it could only be single-digit fuel savings, but that's also significant on a large consumer. Or it could make you be able to operate within certain protected areas under zero emission or low emission opportunities. So those, and then you have the other extreme where you could look at an operator that could be 4xing the entire vessel cost by moving towards some, we talked about earlier, alternative fuel type solution that gets very, very pricey and very, very cutting edge. Really awesome engineering. And if you love engineering, those are great projects. But it could get very, very, very expensive very quickly. The majority of projects are obviously falling somewhere in between. Right now, the markets that we see that have the most significant, bang for the buck is within that ferry segment, the passenger segment. They have the public funding. These are resources that can be used for a long period of time in the transit that it's currently doing or designed for. That they can see the benefit. It's a significant. So we're talking, it could be a 20% or more increased cost to the construction. So it's definitely comes at a premium, but then you'll see the savings gained in either the grant funding that's available with that move, additional funding within the state agencies that are available. You're also increasing the reliability of the vessel. So we see some owners that are looking to maybe reducing their fleet size by having more vessels that have higher reliability, and then needing less assets. So again, looking at that OpEx or long-term plan for operations and what they want to do, and a more expensive asset on the front end may actually have savings in the long term. So that's what we're seeing. That's what people are saying. So it really varies. It's certainly significant, the price increase. I think that's anyone that says it isn't is not being really honest with the details. It is a significant investment, but you also have to be very, again, it comes to this like designing to the budget. Like it's you have to design to what is a good vessel for today, and maybe not the ideal vessel that could be built. Unless if you have the capital to build that perfect vessel, that's great. But if you don't, onboard hybrid vessels we're seeing, especially in the ferry market, where they're saving fuel, they'll eventually be plugged in, is a good steward of the next, when that vessel goes to the midlife, or we look at the Ampere making its transition from hybrid electric to basically operating on all battery at this point, where the generators become just backup power. Like that is what I would advocate for the industry, is kind of finding these, what would be a compromise solution, but is a solution that's exceeds the vessels today, it exceeds the regulations today, but will be adaptable to the future regulations and the future expectations of that vessel.
I just want to pick up on that government funding thread, because, as you know, since January 20th and the new administration, there's been decided a slowing or stoppage of government funding for projects, particularly ones tied to environmental targets. So can you just discuss in the round? I'm not looking to take this down a
Sure. Yeah,
political
no.
path, but how is that impacting majors like Siemens Energy, and how are you responding to this new fiscal reality?
Right. So it's funny, like even a company like Siemens Energy, I forget what anniversary year we're on. So it's obviously we've survived many different political turns within in the global world and everything else. So world wars and everything. So we're in it for the long term. We don't look at business in a kind of very small scale. So if we look at the hybridization, and again, it goes back to those owners like, hey, would you do this all over again? They're all saying yes. So we firmly believe that the technology is the benefits of the technology exceed what is like a temporary type grant to kind of get it started. So that's what we're seeing. But we're also seeing that, we also know that infrastructure is still a big topic of this administration. Building vessels, obviously the shipbuilding program that this administration is talking about is kind of accelerating some of this effort to build things more domestically in the United States. So all of that comes. So it's not that an owner would say like, hey, I was going to build a diesel electric boat, but now I'm going to build a diesel mechanical boat. No, they're really looking at building the best boat they can at that time. So we still see that the federal funding, we saw the latest release from the ferry fund, was still significant. So even though the efforts for emissions may be substituted for the efforts of increasing domestic production and employing more Americans and these types of things, these types of projects do all this. These are all about building vessels in the United States. They're about building a vessel that's going to be viable for the next 30, 40 years. Is still in the interest of the owners, building reliable vessels and new technology. And then the other thing that's important, part of this whole shipbuilding program and why we want a robust U.S. maritime industry, is we're joking about you got to go to Norway for the technology. You got to go. That doesn't make us robust if we're not building to the latest technology. And it's not simply because of government subsidies that shipping companies, do the things they do and make these decisions. It's still a competitive market, and they're still looking at building the best vessel possible and the safest vessel. So I don't see any retraction in the amount of projects that will be built. In fact, I'm hoping to see an increase still in hybrid and electric projects in the United States. I see something else that's kind of important that I think we should advocate for too within the industry, in the maritime industry, is the use of commercial maritime solutions within defense. So that's one of the things that we're working on a few projects, and with DIU, Defense Innovation Unit, and we know that's important to the Navy, is kind of using these fast-moving commercial solutions to strengthen defense. And we've always had a connected maritime industry and civil defense within the Navy and Coast Guard. We've seen over time that the technologies have kind of gone in diverging positions, but I think there's a lot of benefit in bringing these two positions back together. Again, it strengthens both units. So if we see the shipbuilding, we want strength in shipbuilding in the United States. We have the largest vessel owner in the United States Navy in our domestic pool. They develop a lot of technology, they build a lot of vessels, and I think that can also benefit a lot of commercial vessels and merchant mariner vessels also too, that we have this strength within the United States. So even though the United States is not known as being a high volume production maritime location globally, we are certainly known within our U.S. Navy construction that we build the most complex, best vessels in the world, and that a lot of that can be utilized in the commercial and vice versa. And I think both of those industries can help strengthen each other.
Compare the Europe and US today, and I guess what we can learn, adopt, and use to help fast track our own business.
Yeah, I think I love, again, we'll go back to making that reference of grabbing the pony. So there's nothing wrong with building on what someone else has started. I think that's what every smart person does. They don't try to do everything themselves. So when I look at the maritime industry in the United States, it's great to take what we've done in Norway and what they've done, and they've certainly put accelerant to this process, and we can learn a lot from them. But what we've realized is, as you know, is regional vessels operate differently. Again, it goes back to we have different budgets, we operate them differently. So we're going to adapt that technology to what makes sense for our market and our segments of vessel types. So it's a great starting point. There's nothing wrong, in my opinion, in starting with a good base from somebody else. In fact, I think it's just smart that we should do that. If somebody else has kind of started the journey, we should certainly take it. But I think what we're going to start to see is kind of that American evolution that benefits us, and that may be different than the way Norway takes the technology in the next 50 years versus the way Korea may take the same technology in the next 50 years, because they have a certain vessel segment that they're servicing. So I think that the American ability to kind of innovate and to adapt is going to be felt within the technology, and we're seeing that when we have conversations back with our engineers in Norway. They're impressed, or they take note on some of the things that we've done differently with the technology now as it starts to evolve. So I think they were the incubator to kind of start it and to release it into the atmosphere, and now we're going to see where it blooms and where it goes from there.
Obviously, we've talked about some of the challenges that come, and we've looked more so at the ship owner side. Let's kind of switch gears and talk about the naval architects and the ship builders, because that's obviously a massive part of the equation as well. Sticking on North America, US and Canadian shipyards, and I'm not looking for you to call out specific companies here unless you would like to, but can you kind of speak in the round about the ability of the yards here in North America to build and maintain these vessels? And I'm not looking for you to spend their money, but specifically, how must they invest, I guess, in either technology or people to do the job more efficiently?
Excellent. Yeah, so I would put the U.S. shipyards up against anyone else. I love the yards. I love the kind of the nature of getting things done that you find only, I think, in the United States shipyards. So it comes from a necessity. It comes from a necessity of maybe you don't have all the infrastructure you need, or maybe you don't have repetitive vessel types that you can, just lean on the way you did in the past, but you got to kind of innovate as you build. So we see as the U.S. yards, they're very innovative. They're very much, boots on the ground way of thinking and doing things. We learn from them. We're more theoretical and we're more practical, I think, in our approach in some ways. And then they're definitely more in how they get things done. So we learn a lot from the yards. They teach us a lot about, like the actual day-to-day of building vessels and how the equipment has to integrate and how the vessel has to come together. So we appreciate the education we receive from the yards. All of them, it's a journey for sure if they haven't built a hybrid vessel before with a large amount of electrification on board the vessel. But there's nothing there that they can't learn. So and they can do it. They utilize a lot of subcontracted specialties when it comes to some of the termination. If you don't build a lot of high voltage, regulated vessels, then you're going to bring in somebody else who's going to do that termination because you don't have that in-house skill set. But that's, that works too. So it's a combination. And I think for the most part, we hear the feedback is, it's tough for the yards to build the first few. They certainly have some, but they also bid the next hybrid vessels. We very rarely see them not bidding on them. So again, if the testimony is, would you do it again? It seems like they all are kind of saying, yeah, we would do them again. And there's also a fair amount. I think we kind of overlooked the amount of experience that was developed during the offshore kind of boom. All those vessels were diesel electric vessels. Now, maybe they weren't built with energy storage at the time, but there were still kind of diesel electric vessels. A lot of them were produced in the Gulf Coast in the 2007s through 2011, with a lot of knowledge that was learned during that period of time that's being utilized now on whether it be a hybrid ferry or a hybrid tugboat or something like that. A lot of that same technology and same knowledge is being shifted. So it is a journey for the shipyards, but they're up to it. Each yard seems to kind of have their area of expertise that they like to build vessels for. So the projects that we're working on within NASCO, great projects for NASCO. The projects that we're working on in the Gulf Coast with a shipyard like Thomas E, great projects for Thomas E. So yeah, I don't see there's always differences between yards, but there's certainly not an issue with building a hybrid vessel in the United States.
Can you discuss any specific new build projects in the U.S., either going on now, recently completed, whatever, in the works, that really illustrate the ability and the advantages to build the capability of building modern hydrogen or hybrid electric vessels?
Sure. So I guess I'll highlight one. So last year we delivered the new TxDOT vessel as a hybrid electric vessel. I know that they're planning on building a second vessel that should go out to bid in this year. So in this summer. So it's again, whenever a customer is willing to build a second vessel, it's a good sign, or another vessel, I should say, and especially a short period of time, it's a good sign. At Siemens Energy, we have about 8 to 15 different active projects in the marine side in North America. So we have projects that range the side of defense that we're working on, all the way commercial applications, research vessels, federal government in the United States, federal government in Canada, ferry projects. We have a few ferry projects, hybrid ferry projects going on right now, delivering some as of this summer. Retrofits on some interesting projects too. So there's always something. And yeah, if anyone who's out there who's listening and they're thinking about either a new construction in a certain segment or retrofitting in a certain segment, I could give a lot of details on that specific project for sure.